Welcome to this video from In 28 Minutes. Thanks for helping us provide awesome learning experiences to more than 300,000 learners across multiple platforms, Udemy, Safari, and Pact. Let's welcome our lead instructor, RANGA KARANAM. A project manager comes to you and asks, why do we use Spring Framework in our project? Now, how do you answer that question? That's what we will try and discuss in this specific video. You can tell him this Spring Framework is a Java platform that provides comprehensive infrastructure support for developing Java applications. What he would do, he would kick you, right? There is nothing he would actually contribute by providing a definition like that. So, what does Spring Framework really do? Whenever we write code, we would want to write loosely coupled code. What do we mean by loose coupling? Loose coupling is basically that when you change any component, the other components should not get affected. You can look at the to-do business service in here. It's tightly coupled to the to-do data service IMPL. This complex algorithm IMPL is tightly coupled to the bubble sort algorithm. If I change the algorithm from bubble sort to quick sort, what would I need to do? I would need to change the code of the complex algorithm IMPL. Is that good? Nope, right? So why should the complex algorithm IMPL change when I want to switch from bubble sort to quick sort? Is there a better way to implement that? A better way to implement that would be to create an interface called sort algorithm. And in the complex algorithm IMPL, we use the sort algorithm. In the complex algorithm IMPL, I am not going to tell I'm using quick sort or bubble sort. We are just saying I would want to be able to use a sort algorithm interface which has a method called sort. So I would want to use some sort algorithm. It could be quick sort, bubble sort, radix sort, or any of the other sort algorithms. What is this? What are we doing in here? What we are doing in here is called loose coupling. This complex algorithm IMPL is no longer dependent on a specific sort algorithm. So what can I do? Whenever I would want to create a complex algorithm IMPL, I can send what sort algorithm it needs to use as an input to it. Now you might be wondering, where does this Spring Framework come into picture? So we have loosely coupled the complex algorithm IMPL. We have created an interface called sort algorithm. We have created a couple of implementations of quicksort and bubble sort implementing the sort algorithm. And we are creating a new complex algorithm IMPL, passing quicksort algorithm as the parameter. Where does Spring Framework come into picture? The thing is, when you write code with Spring Framework, all that you need to do is you need to create the components and declare their dependencies. So here I am saying this is a component, and here I am saying this is a dependency. The sort algorithm is a dependency. The Spring Framework internally does this. It checks, it does a search through all the components to find a matching thing for the sort algorithm. So it scans through all the classes and sees which is the right match for this sort algorithm. It finds, let's say, quick sort algorithm. And what it does is it creates an instance of the complex algorithm IMPL, passing in quick sort algorithm, and it would instantiate the complex algorithm IMPL. So the Spring Framework instantiates the components and injects the dependencies in. So all that you need to do as a programmer is to define at component, and you can say at autowired, and whichever one of these you'd want to use. So let's say I want to use quicksort algorithm, I put at component on it. What Spring Framework does is it would find the quicksort algorithm, it would inject it in, and it would create an instance of the complex algorithm IMPL. So whatever code you are seeing in here is what Spring Framework does. Now this is called loose coupling, and whatever is happening in here is dependency injection. So you have a component and it has a dependency called sort algorithm. Spring Framework finds that dependency and injects that in. Now you might be wondering, what's the advantage of this loose coupling? The advantage of this loose coupling is, number one is we know. Like tomorrow I would want to switch from quicksort algorithm to bubble sort algorithm. All that I need to do is remove the add component on quicksort algorithm and put it on bubble sort algorithm. Or there are other strategies. There are annotations like primary, qualifier, and other stuff that you can use to make it even dynamic. The second thing that you can do is write a unit test for the complex algorithm IMPL without worrying about the sorting logic. What I can create is a stub algorithm. So I can create a stub algorithm implementing the sort algorithm, and I can use that and I can write a test for the complex algorithm IMPL. That would mean that the complex algorithm IMPL test is not really worried about which algorithm is being used. It focuses on the logic of the complex algorithm. Let's look at one more example. The welcome controller in here, for example, is directly creating an instance of the welcome service. That means it's tightly coupled to it. What would you do if you use Spring Framework? You would say at autowired welcome service. What is the advantage of that? Now, Spring auto-wires in the welcome service. Spring would create an instance of the welcome service and auto-wire it in. Now, the advantage of it is when I'm writing a unit test for this, I can use a welcome service stub. Now, is this the only problem that Spring Framework solves, loose coupling? Nope. Spring Framework also provides you with a lot of modules. You have Spring JDBC, MVC, AOP, ORM, JMS, test, and a wide variety of other stuff. So all these frameworks make it easy to write your code. They help you in reducing your duplication inside code. If you look at any JDBC code, you would have a try, catch, and a lot of code to handle exceptions, which is repeating again and again. And that's something you don't really need if you use Spring Framework. The other problem Spring Framework solves is it's very good at integrating with other frameworks. So it does not try to solve problems which are already solved. For example, if you use Hibernate, then Spring provides a good integration with Hibernate. It provides good integration with iBatis. It provides good integration with JUnit and Mockito for unit testing. It does not try and do what JUnit and Mockito does. It just adds functionality on top of these frameworks, which makes it easy to integrate with them. So what does the Spring Framework do? The Spring Framework allows us to focus on the business logic. It will take care of things like JDBC, JMS, and all that kind of stuff. How do you integrate with them? And it lets us to focus just on the business logic. It takes care of dependency management. It enables testability of code because Spring Framework allows us to write decoupled code. The code is easily testable. It allows for inversion of control. What is inversion of control? When you write code without Spring Framework, this is what we do. Create an instance. Create an instance directly in here. Here, the control. Who has the control? The complex algorithm IMPL has the control of what dependency it is using. What we are saying now is the complex algorithm IMPL does not worry. We just create an interface and we provide a way to inject it in. Who takes care of the injection when you are actually using Spring Framework? It's the Spring Framework. So you are inverting the control. The control goes away from complex algorithm IMPL and the control goes to the Spring Framework to find the dependency and auto-wire it in. That's what is called inversion of control. The basic framework in Spring that does this is called Bean Factory, and the advanced version of Bean Factory is called Application Context. Bean Factory is responsible for identifying the components, identifying the dependencies, creating beans, and injecting the dependencies in. It manages the entire life cycle of the bean. Now, why do you want to use Spring Framework? Because you would want to be able to unit test everything. If everything is loosely coupled, then you would be able to write unit tests very easy. The code is testable. You will have very less plumbing code. You would be able to have a clean architecture, and implementing cross-cutting concerns is easier because of using things like Spring AOP. Spring brings in a lot of architectural flexibility because of its independent module structure, and it provides great integration with other frameworks as we talked about earlier. What are the best practices when you are using Spring? One of the things is Spring Initializer. Just try the website start.spring.io. So just type start.spring.io and it would take you to a website where you can actually create a Maven Spring project or a Gradle Spring project very easily. So all that you need to give is com.example, like the group ID, the artifact ID. You can provide whatever dependencies you would want, generate project, and you can get started with Spring. So that's one of the best practices when you're using Spring framework. The other best practice is think about Spring Boot. Spring Boot makes it very, very easy to use the Spring framework. The third one is always write unit tests. Whenever you're using Spring framework, try and write great unit tests. Now, what are the challenges when you start with Spring framework? One of the important challenges is the fact that it's little difficult for a starting programmer to understand it. But once you understand it, you cannot stop using it. What are the other things you would need to know about Spring? One of the important things is Spring modules. What Spring offers a number of modules. Spring JMS, Spring JDBC, Spring AOP, and a wide variety of other stuff. So you might want to look at all of them. The other thing is Spring projects. There are a wide range of projects that are done under the umbrella of Spring framework. Spring Cloud, for example. Spring Web Services, for example. And we have a great course on Udemy for Spring framework as well. As you can see, it's one of the best-selling courses for Spring framework with amazing reviews. It has about 60,000 reviews, and spend some time reading these reviews and you'd see that it's an excellent course. In 28 Minutes is providing awesome learning experiences to 300,000 learners across platforms like Udemy, Safari Online, and Pact. We have clocked million hours of learning in the last few months. The question is, what do you want to learn next? We are building solutions to help programmers at all levels. You can learn programming with our awesome courses on Java, Python, and JavaScript. You can learn full stack development with REST APIs and microservices with a wide range of frameworks like Spring Boot, Node.js, React, Angular, and Spring Cloud. We have 200 plus videos to help you start your journey from a programmer to a software architect. We have videos to help you learn frameworks, industry trends, including things like microservices, learn the best practices in architecture, design, and code quality. Thanks for watching. Keep learning in 28 minutes.